The pH also influences biochemical energy storage. Ions pass through biological membranes only slowly if unaided by protein pumps, channels, or carriers that traverse the membranes. Cells of most organisms exploit this low membrane permeability to store energy. When surplus energy is available, they pump protons across the membrane and establish a proton concentration gradient. To retrieve this energy, cells let these protons flow back across the membrane through integral membrane proteins called proton ATPases. The flow of protons through a proton ATPase produces the high-energy compound ATP. The interplay between structure and function of proton ATPases is fascinating. As protons flow from a compartment with a high concentration of protons to one with low concentration, they pass through a channel in a protein that causes several subunits to rotate. Some of these subunits form a complex with ADP and phosphate, and as they rotate, conformational changes in the subunits squeeze the ADP and phosphate together and generate ATP. This process is analogous to placing a water wheel in a flowing stream and using the resultant rotational motion of the wheel to run a press that makes high-energy bars. Acidic or alkaline environments may interfere with establishing or maintaining pH gradients across biological membranes, and thus disrupt cellular energy production. Organisms can compensate for short-term disruptions, but long-term disruptions may prove toxic. This is yet another reason why organisms buffer themselves against pH extremes. The pH of a solution determines the solubility of several elements that are essential for life. For example, in an aerated solution with a pH above 8, ferric iron precipitates as the extremely insoluble ferric hydroxide, with the consequence that iron may not be available for absorption by organisms. Difficulty in maintaining iron in a soluble form impairs the treatment of iron deficiency anemia. The solubilities of most other metal ions are also strongly pH sensitive. The pH alters the structural integrity of many organisms through its effect on calcium salts. Tooth and bone of vertebrate animals are composed primarily of calcium phosphate in hydroxyapatite crystals. Shells of animals with exoskeletons are composed primarily of calcium carbonate crystals. These calcium compounds become more soluble at acid pHs. To maintain the structural integrity of calcium compounds is one reason that toothpaste, blood, and seawater have alkaline pHs.